Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. An insurance company categorizes its policyholders into three mutually exclusive groups: high risk, medium risk, and low risk. An internal study of the company showed that 45% of the policyholders are low risk and 35% are medium risk. And of course, if you look at this, you see immediately that the remaining 20% have to be high risk. The probability of death over the next year, given that the policyholder is high risk, is 2 times the probability of death of a medium risk policyholder. The probability of death over the next year, given that a policyholder is medium risk, is 3 times the probability of death in a low risk policyholder. The probability of death of a randomly selected policyholder over the next year is 0.009. Calculate the probability of death of a policyholder over the next year, given that the policyholder is high risk. And here's a solution. So in problems like that, you may remember I tell you in my study manual to always begin by labeling the events. The events that we're working with are, the event D is death of a policyholder, H, high-risk policyholder, so event that a randomly chosen person is a high-risk policyholder, M, medium-risk policyholder, L, low-risk policyholder. We are given in the problem that probability of D is equal to probability of D given H times probability of H. Well, we're given this by the fact that H, M, and L form a partition of the probability space, so I probably should phrase it this way. Because H, L, and M form a partition of the probability space, probability of D is equal to probability of D given H times probability of H, plus probability of D given M times probability of M, plus probability of D given L times probability of L. Okay, but probability of D is given as 0.09, and probability of D given M is 0.5 of the probability of D given H, and probability of D given L is a third of what probability of D given M is, so it's a third of a half of probability of D given H. So therefore we get this equation that 0.09 is probability of D given H times probability of H, plus 0.5 times probability of D given H times probability of M, plus 1/3 times 0.5 times the probability of D given H times probability of L. And probability of H is 0.20, probability of M is 0.35, and probability of L is 0.45. So we plug that all in, and this expression just becomes, if you calculate everything, 0.45 times probability of D given H. So 0.009 is equal to 0.45 times probability of D given H. Well, therefore, probability of D given H is equal to 0.009 divided by 0.45, and that's 0.02, which is answer B. Please remember, this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.